Good afternoon. Today we are going to see the problems of space forces, and that is from 2019 paper. Now, my channel is Civil Engineers Technical Hub. If you are not subscribed, you can subscribe. And in this, you have to go to playlist. In playlist, you have engineering mechanics, and in this, you have different videos over there. And you can see these videos to solve the problems of engineering mechanics. So now we will go with this December 2019 paper, and we are interested to solve the paper that is from Space Forces. So now we have given this problem, and in this problem, we are interested with tension in each wire. So you can see OA is kept in vertical position using 3 guy wires AB, AC, and AD as shown in figure. Calculate the tension in each wire if the weight of the pole is 5,000 Newton. So this weight is acting downward in this pole. So at this point, we have this will be 5,000 Newton upward. So now we have tension in each cable. So we have in this fashion. It will take a little bit more time. So now we have to write coordinates. Now we will start with A. A is on Z axis. So my X and Y coordinate is 0. So I have 0, 0, and vertical is given. This is 5 meters. Then we have to go coordinate B. Now you can see coordinate B is on Y axis. So if it is on Y axis, my values of X and Z are 0, and Y we have towards negative, Y shown here. So on this side we have Y positive, on this side we have X positive, and Z direction we have positive. So now 0, this is opposite side, so -5 and 0. Now Y coordinate of all these points are 0 because this plane is in X, Y axis, and this is passing through origin. So XY plane passing through origin. So coordinates along Z are 0. Then we have C. So X direction we have 5. X direction we have 1 parallel to X axis. From Y axis we have 1 meter. So this is 1. X is measured parallel to X from Y. So 1. Y parallel to Y from X. This is 5 meters. And then Z we have 0. Already I mentioned this. And then D parallel to X axis but is in opposite direction. So we have -1. Then Y we have parallel to Y axis from X axis. So this is 5 again in the line of C, and Z we have 0. So now we have this. Now we have equilibrium at joint A. So we have concurrent forces at A. Concurrent forces at A. So now we have to see this. T bar AB. So we have T bar AB. This is equal to TAB into B bar minus A bar upon AB. So now, why I have taken B bar minus A bar? I am taking joint A, and at joint A we have this arrow. This arrow is going towards B. So we have B bar minus A bar. And then we have to put the values. TAB, B bar minus A bar. So B we have 0, A we have 0. So 0I. Then we have -5, 0. So we are actually doing over here B bar minus A bar means x2 minus x1I plus y2 minus y1j plus Z2 minus Z1K. And then AB we have root of all these values. X2 minus X1 whole square plus Y2 minus Y1 whole square and plus Z2 minus Z1 whole square. And therefore we have 0, then we have minus 5J, and then we have 0 minus 5, and that is minus 5K, and divided by now root of 0 plus 25 plus 25, so that will be 50. 25 square plus, sorry, 5 square 25 plus 5 square 25, so it will be 50. Then we have T bar AC, that is equal to 2AC in bracket C bar minus A bar divided by AC, or you can write CA, one and the same thing. So now we have TAC in bracket. Now see here we have 1 minus 0, so we have I. Then 5 minus 0, so we have plus 5J. And then 0 minus 5, so minus 5K. And divided by, now this is 1 square plus 5 square plus 5 square. And this will be root 51. And we have third, T bar AD, and that is equal to TAD in bracket D bar minus A bar divided by AD, and that is equal to TAD in bracket D bar we have minus 1, 0, so minus I plus 5 minus 0, 5J, and minus 0 minus 5 minus 5K, and this will be as it is, root 51. So we have T bar AB, T bar AC, T bar AD. Now I will write here one component only. So summation Fx equal to 0. So we have X component, we do not have for AB because I is 0. AC we have I. So we have TAC upon 51. TAC divided by root 51. Then we have TAD minus I upon root 51. So we have minus TAD upon root 51. And this is my equation 1. Then I will write in y direction summation Fy equal to 0. Then we have in y direction, this will be minus 5 TAB upon root 50 minus 5 TAB upon root 50. Then we have TAC, here we have 5, so plus 5 TAC upon root 51 plus 5 TAD upon root 51, and that is equal to 0. This is my equation 2. And then I have FZ0, and then we have in Z direction, first is same minus 5 TAB upon root 50. Then we have plus, sorry, we have minus, because for TAC, we have this value minus 5K. So minus 5 TAC upon root 51 and minus 5 TAD upon root 51. And then we have this will be plus 5,000. And therefore we will get third equation. Therefore we have third equation minus 5 TAB upon root 50 minus 5 TAC minus 5. Just a minute, I will rub this so we do not have more space. So we have minus tau minus 5 TAC upon root 51. Then we have minus TAD again 5 root 51. And this 5,000 will go on this side, which will be minus 5,000. And then this will be my equation 3 now. Now I will solve these three equations. And by solving these three equations, I will get value of TAB, magnitude we are mentioning, 3535, 0.53 newtons. Then we have TAC, these are tension in cables, 1785, 0.36 Newton, and TAD, we have same 1785.36 Newton. Do not afraid these two values are same, because if you will see this equation, from this equation, you will come to know your value of TAC and the value of TAD should be same. And we have these values same. So likewise, we have to solve this problem. So now we have this problem, a square mat, foundation support 4 columns shown in figure. Determine the magnitude and point of application of resultant. Now we have seen, if you will see the lecture of theory, then we have simply R is equal to summation Fy. And then I will get R, this is equal to, so we have four forces, 40, 12, 8, and 20, all downward. So minus 40, minus 12, minus 8, minus 20. So it will be minus 80 kilonewton. Or I can say R is equal to 80 kilonewton, which will be downward. Now, if we will see the coordinates, so if I will say this will be force A, then this is again XZ plane. So my Y coordinates are 0, because now vertical is Y and your plate is in XZ plane passing through origin, and therefore all Y are 0. Here we have origin, so we have all 0. Then 12 is on X-axis, so we have Y and Z 0. Parallel to x, we have distance 4 plus 6. This is parallel to x. So x is 10, y 0, z 0. Then we have this, I will say B point. Then we have C point. Then parallel to x. So this is x. X-axis. Parallel to x, we have this distance. This is again 10. Parallel to y is 0. Parallel to z, we have this distance, which is 5 meters. Then we have this as D point. At D point, we have parallel to x, we have this distance, which is 4 meters. Parallel to y, 0. And parallel to z, we have this distance, 5 plus 5, 10. And now we know we have x equal to summation fx upon r. Now, so x equal to summation fx, we have this will be first 40. So 40 into 0. Then we have second 12. So 12 into x coordinate, 12 into 10. Then we have third, that is 8. 8 into again 10. And then we have fourth, that is 20. 20 into 4. So 20 into 4. And divided by R is 80. And if we solve this, we will get x equal to 3.5 meter. Then we can find y, which will be summation Fy upon R. Now summation Fy, 40, sorry, Now we have Z, not Y, because our y-axis is vertical and we are plane that is in xz, and therefore we have to find z coordinate. So don't make mistake which I made over here. So you have to write summation fz upon r. Then I have 10, 40 into 0, then 12. This is on x-axis. So I have z0. Then I have 8 into, we have 5, plus we have 20, and z we have 10 divided by 80. And then we have, this will be 3 meters. So we have a resultant R, we have 80 kilonewton, and coordinates we have 3.5, y is 0, and z is 3. Means if I will try to plot it, x I have 3.5 and y I have, z I have 3. So it may be somewhere here. So we can plot it roughly 80 kilonewton, and coordinates we have 3.5, 0, and 3. So likewise, we have to solve these problems of parallel forces in space. So now we will stop here only. So thank you. If you are not subscribed, subscribe this channel, Civil Engineers Technical Hub. So now we will stop here only. So thank you.